For this problem, we're going to use the definition of the derivative to find the derivative of this function. So the definition derivative looks like this. The derivative function f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So in this particular case, it's going to look like this. The limit as h goes to 0 of x plus h squared minus 1 over 2 times x plus h minus 3 minus x squared minus 1 over 2x minus 3. That's all divided by h. So that h can just go in the denominator. So what we're going to do is expand this and get a common denominator. Okay, so I'm going to write this out as the limit as h approaches 0. I'm going to expand the numerator, so I'm going to get x squared plus 2xh plus h squared minus 1. And getting a common denominator, I'm just going to multiply that by 2x minus 3 minus, this is going to be x squared minus 1, and I'm going to multiply by that, the denominator here. Okay, and I'm going to simplify that to 2x minus 3 plus 2h, like that. Okay, and that's going to be all over the common denominator of 2x minus 3 plus 2h times 2x minus 3, and then I'm going to put the h in the denominator here. Okay, so this is now looks a little bit simpler, so we're going to expand and combine like terms, and hopefully we have enough x terms to cancel out to get rid of this divide by h. Okay, because that's our goal. So we end up multiplying this out, 2x cubed minus 4x squared h plus 2xh squared minus 2x, and then multiply everything by negative 3, so we get negative 3x squared minus 6xh minus 3h squared plus 3. Okay, so that looks about right, and then minus, and I'm going to put everything in brackets here, 2x squared, okay, minus 3x squared, or sorry, this should be minus 2x cubed. Okay, we have to be really careful with this multiplication, plus 2x squared h. Then I'm going to multiply everything by negative 1, so I'm going to end up with negative 2x plus 3 minus 2h. Okay, so there's my numerator all expanded. So I'm just going to look for common terms to cancel out. So I see I have 2x cubes that cancel out. Looks like I have plus 3x squared here, minus 3x squared here. 2 plus 2x squared h. So that becomes a minus 2x squared h. Oops, that's not x squared h, so I'm just going to double check that. X squared h's, so I have 4x squared h's. Okay, so I'm going to group together these terms. Those are like terms. And 2x minus 2x, negative minus a negative. Plus 3's cancel out here. And I don't have a minus 2h, so it looks like everything cancels except for these two terms in the second part here. Okay, so now I'm just going to combine my like terms. Okay, so we have to be very careful with these steps in here, because once you make one error, it's going to mess up the results. So you have to be very careful. So watch my signs and everything. So I have minus 4x squared h minus 2x squared h Okay, so that's going to be, that's going to be plus 4. I made a mistake with my signs here, didn't I? So that should have been plus 4x squared h. Okay, so just double check my signs again. Okay, so that should have been plus 4x squared h. So we're going to end up with 2x squared h when I combine those like terms. Okay, that's the only like terms I have, so then I end up with 2xh squared minus 6xh minus 3h squared, and this is going to be plus 2h. Okay, so now I have all my terms in my numerator has an h factor, which allows me to cancel with that h factor in the denominator. Okay, so this h in the denominator, which I want to get rid of, now I can get rid of by canceling out some of these terms. So pretty soon I can apply my limit. So this is going to be 2x plus 2x squared plus 2xh minus 6x minus 3h plus 2. So all the terms with h's, when I apply my limit, those terms will disappear. The denominator now becomes 2x minus 3. This disappears here, so we end up with 2x minus 3 squared. So as I apply my limit, I end up with 2x squared plus 0 minus 6x minus 0 plus 2, and that's all over my denominator of 2x minus 3 plus 0, 2x minus 3, and our final answer then becomes 2x squared minus 6x plus 2 all over 2x minus 3 all squared. Okay, so there's my derivative function using the Newton's quotient. Now this is really fairly intense algebra here. So we will have a simpler way to do this when we have some rules to differentiate, but using the definition of the derivative, it looks like this, and this is what my derivative looks like.